Today we will discuss about electric current. In our syllabus we are having chapter current electricity. So in which we are having one topic electric current. We already studied Ohm's law, and in the Ohm's law we obtained three physical quantities: voltage, current and resistance. So in this class we will discuss electric current. So what is the electric current? Electric current is flow of charges. What is the electric current? Electric current is what? Flow of charges. In the conductor, flow of charges is what? Electric current. What I am saying, one wire we are having, and in which flow of charges will be what? Electric current. Clear? In mathematically we can say current is what? Charge per unit time. Charge per unit time. What? In mathematically we can say current is charge per unit time. Current is denoted by I, charge is denoted by what? Q, and time is denoted by T. So we can say current is charge per unit time. And what about the charge? Current is what? Flow of charges. Clear? And charge is what? Charge is, we will discuss separately, but I am just giving some basic idea. Charge is what? Deficiency of, what is the charge? Charge is deficiency of electrons in a body. If you are having any object and in which, or any conductor, in the conductor deficiency of electron, that is what? Charge. Charges are what? Negatively charged. A body is negatively charged. It means what? It gains electron. Two types of the charged particles: negatively charged particles and positively charged particles. What we are discussing about the charge. Charge is deficiency of electron. We'll discuss separately in detail, but I'm just giving basic idea about the charge. Charge is deficiency of an electron. Clear? A body is negatively charged. It means it gains electron. Clear? And a body is said to be what? Positively charged. It means what? It loses electron. If electrons gain, it means negatively charged. Loses electrons means positively charged. Clear? Don't worry about these things. Only you should know we are discussing current, and current is what? Charge per unit time. What is a current? Current is charge per unit time. Charge upon time. Clear? And it is flow of charges. In a conductor, in a wire, flows of charge is what? Current. Clear? In another way, how we can say, if n number of free electrons are passing in a conductor, we are having one conductor and in which n number of free electrons are passing, like this one. This one is what? One conductor, in which n number of free electrons. Electrons are what? Negatively charged. So minus n number of free electrons passing in a conductor. So what we can say? Number of free electrons in a conductor is what? This is the conductor. This conductor means what? In the conductor, current can easily flow. What is the conductor? Conductor is it is the type of the material, and that material in which current can easily flow, that is called what? Conductor. Metal. Clear? And they are made of what? What? They are made up of what? Aluminum, copper and iron. So in the conductor, current can easily flow. So this is the conductor, and in which what is happening? Current is flowing. What is happening? Current is flowing means what? Electrons flows of the charges. And we are discussing what if n number of the free electrons are passing in a conductor, then total charge will be what? This is what? One circuit. Circuit is a closed path having some elements. We are having one active element and one. This is what? Conductor. This is the conductor. Another way we can say this will be what? Passive one. At the place of this one, we can use resistor, inductor, capacitor, and they are what? Passive elements. So this is the conductor, and in which current is flowing. Current is flowing means flows of charges. Charges are flowing. And what is happening? N number of free electrons are passing in a conductor. One is the flow of the charges. One is what? Flow of the charges. And other one is what? Flow of electrons. Both are different. One is the flow of charges and one thing is what? Flow of electrons. In a circuit, we are having one cell. This is the positive terminal. This is the negative terminal. Electric current or what? Flow of charges starts from positive terminal. What? This is the cell. Flow of charges starts from positive terminal of battery to negative terminal. What I am saying? In the circuit, flow of the charges, or we can say electric current, starts from positive terminal of battery to negative terminal of battery. So direction of electric current in a circuit is what? Current flows from I is what? Current. It starts from positive terminal to negative terminal. But in the conductor, we are having free electrons. They flow in opposite of this direction. Observe carefully. In the conductor, we are having free electrons, and direction of flow of these electrons is what? Opposite of this current. Opposite of this electric current. When current flows from, it is starting from this way, flowing this way, A to B. Current is flowing A to B. It means in this conductor, electrons will flow opposite of this one. Current is coming this direction from A to B, and electrons flow. Conductor having electrons, and in which flow of direction is what? Electrons flow direction is what? Opposite of this conventional current direction. Normal electric current is what? Conventional current. And this is the electron flow. So this is what? Electronic current, we can say. So we understand that what? Now observe this one. If n number of free electrons are passing in the conductor, in this conductor, how many numbers of free electrons we are having? N numbers. N numbers of free electrons are passing in a particular time. So n number of free electrons are passing in a conductor, then total charge. Then if conductor having n number of free electrons, then total charge will be what? Total charge will be n times of E. Observe carefully. We want the charge, if conductor, we want the charge of a conductor. Conductor having n number of free electrons, then n number of free electrons will be multiplied by 1 electron charge. E is what? E is what? 1 electron charge. And what is the 1 electron charge? It is what? 1.6 into 10 to the power minus 19 coulomb. Clear? So how we will find charge in a conductor when n number of free electrons are passing? It means total charge will be n times of E, n into E, n will be what? N is what? Number of free electrons, and E is what? 1 electron charge, and it is having standard value. Electron charge is what? 1.6 into 10 to the power minus 19 coulomb. Clear? Charge having unit what? Coulomb. So it is the charge, so its unit will be what? Coulomb. Now observe, Q is the NE, then current will be what? Current is charge per unit time. We will put Q equal to NE, then our formula will be what? I equal to NE upon T. So from these 2 points, what we are getting? Current is charge per unit time, and another when we can say if n number of free electrons are passing in a conductor, then total charge Q equal to NE, and then current will be what? NE upon T. This is another formula of a current or electric current. Clear? This is the basic current. Current is what? Normal. Once we talk about the current, it is the flow. It is the what? Flow of charges. Flow of charges. And what about the charges? Deficiency of electrons. Deficiency of electrons. And a body is negatively charged means a body is negatively charged. It means what? Gains electron. It gains electron. Positively charged means loses electrons. Clear? This is the basic of what? Charge. We'll discuss separately in the charge topic. It is linked to chapter number 1. Clear? Now we want average electric current and instantaneous current. Two things we will discuss now. One is the average electric current. How we will find? Current is what? Charge per unit time. That's okay. Charge upon time. If charge is unit is what? Coulomb. Time unit is what? Q is the charge, its unit is coulomb. T is the time, its unit is second. And I is what? Electric current is denoted by I. We can also use small I, no problem. Capital I or small I we can use. I equal to what? Current. And its unit will be what? What will be its unit? Its unit is, observe, Q is the coulomb, T is the second. So we can say a current is having coulomb per second. Current unit, electric current having unit what? Coulomb per second or ampere. Standard unit we are having SI unit. What is the SI unit of current? Is ampere. So what is the unit of current? Q upon T. Q is coulomb, T is second, T is the time, so it will be in the second. Coulomb per second or ampere. Ampere is the name of the scientist. So current unit is given on the name of the scientist, ampere, and its symbol is what? Ampere, or we can say capital A. It is the notation. Its symbol is what? A. So sometime we observed that in the question given 5A. So that is what? 5A is what? This is the current. 5 ampere current. 5A is what? 5 ampere current. Clear? Now, how we will define its dimensional formula? In the 11th class, in the 11th standard, in the first chapter of physics, you studied dimensional analysis. Or in the dimensional analysis, you observed what is the dimensional analysis? Representation of the physical quantities in the MLT form. Representation of the physical quantities in the MLT is what? Dimensional analysis. So we want the dimensional formula of electric current. So what will be the dimensional formula? It is what? Fundamental quantity. What? Observe, electric current is what? Fundamental quantity, or we can say base quantity. So physical quantities is what? Those quantities which are measurable, and there are two types. One is the fundamental or base quantities, and second one is what? Derived. Derived quantities are derived from two or more base quantities. Clear? So this is what? Fundamental quantity. Current is what? Fundamental quantity. So what we can say, its dimensional formula will discuss later, but it is the one of the 7 base quantity. It is electric current or current is one of the 7 base units. We are having 7 fundamental quantities. Out of these, we are having electric quantity as a base quantity. So how many quantities are fundamentals? 7 base quantities we are having. First one is length, second one is mass, third one is time, fourth one electric current, fifth one is what? Temperature, then luminous intensity, what? Luminous intensity, and seventh one is what? Amount of substance. Clear? Amount of substance. Length, mass, time. Clear? Then electric current, temperature, luminous intensity, and finally amount of substance, or we can say amount of matter. So these are 7 base quantities or fundamental quantities. Out of these, this one is clear. So we can say it is one of the 7. It is one of the 7 base units. Clear? Now, then how we will find the dimensional formula? 7 base quantities having their own dimensional symbol. So current is having its dimensional symbol is what? What is the dimensional symbol of current? Current is the base quantity and its dimensional symbol is A. So we can say in the MLT M0, L0, T0. MLT are what? Dimension of MLT is what? 0, 0, 0. But A is having 1 time. So its dimensional formula is M0, L0, T0, A1 in a square bracket. So this one is what? Dimensional formula. For the competition of NEET and JEE, these points are so important, so you can observe carefully. So dimensional formula we discussed, unit we studied. Now we want average current and instantaneous current. 2 things. So how we will find average current and instantaneous current? Average is what? What is the average? Average is mean. In the mathematics, what we are doing in the average? If we are having 4 numbers, we want the average of these 4 numbers. How we will find the average? We will sum all the numbers. We will sum all the 4 numbers and divided by 4. This is the mean, or we can say average. But in the current, what will be the average current? Average electric current is what? This will be what? Same process we will follow. Delta Q upon delta T. Observe, read. If delta Q charges are passing in a conductor, what we want? Average. So delta Q charges are passing in a conductor. This is the conductor, or in which what is happening? This is the conductor, and delta Q charges flowing in which? And delta Q. So delta Q charges passing in this conductor. Clear? So delta Q is total charge and delta T is what? Time interval we are having. Then average will be what? Delta Q upon delta T. So this is what? Average electric current. Now we want the current at time T. At the instant T. At the time T we want the current. So what we will do? We will do what? We will take limit of delta T tends to 0. We will take limit of this one. Whatever average current we are having, if we limited at delta T tends to 0, then we are getting the current at time T. At the particular instant we are finding the current, so that is called what? Instantaneous current. So at the particular time T we are finding the current, so I of T. At the T, current will be what? Limit. LT is what? Limit. We can also write LIM, limit. Both are correct. LT and LIM both we can use. LT is the limit, LIM is also what? Limit. So limit delta t tends to 0, average electric current. This average, how we will find the average? Delta q upon delta t. Delta q is what? Total charge. Total charge, how we will find? If n number of the electrons we are having, free electrons we are having, then total charge will be what? Ne. Clear? This is the total charge, and time interval is given in the question, then we will put there and solve. This will be what? Average electric current. Clear? And put this value there and limit a delta t tends to 0. I average is what? Delta q upon delta t. When we solve this one, what we are getting? Delta q upon delta t. Delta q upon delta t will be changed into dq by dt, and dq by dt is what? Rate of change of charge. So instantaneous current is what? Instantaneous current is rate of change of charge. Change in charge upon change in time. Getting or not? Delta q is the total charge. Delta q is what? Total charge. And delta t is the time interval. It is the average one. But instantaneous current at a instant t, at a time t, it what? Electric current is rate of change of charge. So from the instantaneous current at the time t, what we are getting? Rate of change of charge. Change in charge upon change in time is what? Instantaneous current. Clear? Now how we will find change in charge? At T1 we are having charge Q1, at T2 we are having charge Q2. So change in charge. Change in charge means dq will be what? Q2. Which one is more? We will take as Q2 minus Q1. This is the change in charge. Q2 minus Q1 and delta t dt. Sorry, dt will be what? Time interval T2 minus T1. So what we can say? dq upon dt will be what? Q2 minus Q1 upon T2 minus T1. For the time T1 charge is Q1 and T2 charge is Q2, then we can write like this. Are you getting or not? Observe, small topic we are discussing, electric current. It is important for the current electricity, and in the current electricity we studied Ohm's law. In the Ohm's law we are having three physical quantities: voltage, current and resistance. So we are discussing one by one each physical quantities. So in this class we are discussing what? Electric current. Basic, it is flows of charges. It is flow of charges. Clear? Where? In the conductor. In the conductor, flow of charges is what? Electric current. And this is a current. This is what? Conductor in which current flow. Electric current flows, or we can say flow of charges is what? A to B. And opposite of this one, B to A will be what? Electron flow. And mathematically we can say it is charge per unit time. If n number of free electrons are in a conductor, then total charge Q equal to Ne, and current will be Ne upon T. N is what? Number of free electron. E is what? Electron charge. One electron charge is what? 1.6 into 10 to the power minus 19 coulomb. Or N is what? Number of free electrons. Clear? This is the basic current or electric current, and its unit is what? Coulomb per second and ampere, and its dimensional formula is m0 l0 t0 a1, and what? It is the one of the 7 base units. We are having 7 fundamental units. Out of these, current is 1. Clear? After this one, we are discussing about what? Average current and instantaneous current. Average current and instantaneous current. So average will be what? Average current will be total charge upon time interval. Total charge upon time interval will be what? Average one. And it is total charge is delta Q, and time interval is this one. Clear? And instantaneous, we want the current at time t. At the time t we want the current, then we will use limit delta t tends to 0 of average current. Average current, this one we will put there. When we solve this one, we are getting dq by dt, and this is what? Rate of change of charge, or what is the meaning? Change in charge upon change in time. At the t1 charge q1 and t2, at the time t1 charge q1 and t2 charge q2, then dq will be what? q2 minus q1. We can use the capital letter, no problem. q1 and q2 we can use capital, there is also no problem. Clear? So we can say I am using small this one. So dq will be what? q2 minus q1. Clear? And delta t, change in time will be what? t2 minus t1. But you all are in the 12th standard, or you know what? Basic of the differentiation and integration. So d by dt is what? Differentiation of charge with respect to t. What we are doing? We are doing differentiation of charge. If we are having charge, then we do differentiate this one with respect to t, then we can find the instantaneous current. Some things are remaining. Current is having both direction and magnitude. Observe this diagram. Current starts from positive terminal to negative terminal. It is having fixed direction. But it is having direction and it is also having magnitude. Measurement, it is having measurement. 5 Newton, 10 Newton, 12 Newton. These are what? Magnitude, measurement. So current is having both magnitude and direction. And if any quantity having magnitude and direction, then that quantity is what? Vector quantity. Clear? But current is having both direction and magnitude, but it is not a vector. What? It is a scalar quantity. Current is having both magnitude and direction, but it is not a vector. It is a scalar quantity. Why? It does not follow additions rule of the vector. Vector having some additions rule. In the motion in a plane 11th standard, we studied what? Addition rules of the vector. So this quantity electric current does not follow addition rules of the vector. So it is not a vector, it is a scalar quantity. So important things we should know. It is a scalar quantity. Now next point, what is this? Current in our nerves, in the nerves are in microampere. So in the nerves, current is in the, sometimes it can be asked in the objective questions, so we should know currents in our nerves are in microampere form. Clear? Now how we will define 1 ampere current? Now this is the definition of the 1 ampere. We know ampere is the unit of a current, but how we will define 1 ampere current? If 1 coulomb of charge passes in a conductor in 1 second. Observe, this is the one conductor in which 1 coulomb of charge is passing in 1 second. 1 coulomb of charge passing in 1 second, that is called 1 ampere. Clear? And what is the 1 ampere? 1 coulomb charge passing in a conductor 1 second is what? Current in 1 ampere. Clear? This is the easy definition. We can define the 1 ampere. 1 ampere is what? 1 coulomb charge passing in a conductor in 1 second is called current. Is called what? 1 ampere current. Clear? Now we already studied this one, direction of the electric current. In the conductor, current flows from positive terminal to negative terminal, or in which current is flowing where? A to B, but electrons flow is opposite of conventional current. This is the conventional current. Electron flow will be opposite of this current. Now I am going to solve one question linked to this topic. What is the question? What is the current flowing through a conductor? What is the current flowing through a conductor? If 1 million electrons, we want what? Current we want. What we want? Current. In the question, starting statement, first statement we are getting, we want current. If 1 million electrons are passing in 1 millisecond. Now how many electrons are passing? 1 million. Number of free electrons n. 1 million. If 1 million electrons are crossing in 1 millisecond, it means number of free electrons are what? 1 million. N equal to 1 million. And 1 million is what? Million is what? 10 to the power 6. So how many electrons are passing? 10 to the power 6 electrons are passing in the conductor in 1 millisecond. Timing is also given. 1 million electrons, this is the n, in time 1 millisecond. So 1 millions in 1 millisecond, and millisecond is what? 10 to the power, milli means 10 to the power minus 3. So this is what? 1 into 10 to the power minus 3 second. What we want? Current. And 1 million, 1 millisecond through a cross section of it. In a conductor, 1 millisecond, how many electrons are passing? 1 million electrons. So n equal to 1 million, time is 1 millisecond, and current we want. Charge of an electron is given as what? Charge of electron we already know, 1.6 into 10 to the power minus 19 coulomb. So we want current. So what is the formula of current? Current equal to charge per unit time. Yes or no? Current is what? Charge per unit time. And for finding of the charge, we are having total charge will be n times of E. If number of the free electrons are given, then charge will be what? N E. E is what? E is what? E is the free electrons. It is given in the question. What? We are having E equal to 1.6 into 10 to the power minus 19 coulomb. It is given, or we already know this is a standard value. So what will be the current? I equal to Q upon T and E upon T. So we can write N is what? N is 10 to the power 6 into 1 electron charge is 1.6 into 10 to the power minus 19 coulomb, and time is what? 1 millisecond. 1 into 10 to the power minus 3 second. Why? Because current is having coulomb per second. So time should be in the second. We cannot use millisecond. So time should be second, and charge is in a coulomb. So don't worry about this one. It will be as it is. 10 to the power 6 into this one. We will solve. How we will solve? Once we 10 to the power 6 into 10 to the power minus 19. What we are getting? 1.6 into 10 to the power minus 13. Yes or no? Base is equal, both are having equal base, then power will be added. Minus 19 plus 6 will be what? Minus 6. We are subtracting 6 from this one. So minus 19 plus 6 will be minus 13. In the denominator what we are having? 10 to the power minus 3. So finally what we can say? 1.6 into 10 to the power, when this negative, this is the negative, brings this from denominator to numerator, then this will be positive. Then what we are getting? 10 to the power minus 13 into 10 to the power plus 3. So again we will observe this one. 10 to the power minus 3 into 10 to the power 3. Yes or no? We can write like this. 1.6 into 10 to the power minus 3. This is in the negative. So once we bring this one towards the numerator, then what we are getting? This negative will be positive. So we are getting. Now base is equal in the multiplication. So we will add the power. When we add both one, then minus 13 plus 3 will be what? Minus 10. So what we are getting? 1.6 into 10 to the power minus 10. 1.6 into 10 to the power minus 10. What is this? This is the current. So its unit is ampere. So its unit is what? Ampere. So we are getting what? 1.6 into 10 to the power minus 10 ampere. Observe again what we are doing. What is the current flowing through a conductor if 1 million electrons are crossing? So total number of the free electrons is what? 1 million. Million means 10 to the power 6. What is the time? 1 millisecond. Milli means 10 to the power minus 3. Clear? Million means 10 to the power 6 and milli means 10 to the power minus 3. through a cross section of it. Charge is this one, charge of one electron is given us. We want current equal to charge per unit time. We are having number of free electrons, so this charge will be Ne, and given we are having E also, we are having, put both there, and time is also we are having. We are putting the values, we are solving, we are getting what is the current, 1.6 into 10 to the power minus 10 ampere. So in this class what we are discussing, electric current. It is your chapter current electricity. You are having one chapter current electricity, and for understanding of this chapter we should know these physical quantities. In the last class we studied what, Ohm's law, and the Ohm's law we are having three physical quantities, voltage, mainly we are having three physical quantities, voltage, current and resistance. So today in this class we are discussed what, this one, electric current. In a short I am revising, electric current is what, charge per unit time. It is flow of charges. It is what, flow of charges, charge per unit time. If in a conductor n number of free electrons are passing, crossing, then total charge will be what, Ne. Then formula will be I equal to Ne upon T. E is the electron charge, its value is this one. It is standard 1.6 into 10 to the power minus 19 coulomb. It is the electron charge. One electron charge is this one. Clear? For average one, how we will find the average current? Average current is what, total charge upon time interval. Total charge and time interval. At T1 charge we are having, T2 charge we are having, then what we will observe, total charge and total time interval. Clear? And this will be what, average current. Once we obtain this value, then we can find current at time t, that is instantaneous current, for which we will use limit of delta t tends to 0 of average current. We will put there, so then we are getting dq by dt, and dq by dt is what, rate of change of charge. Rate of change of the charge is the electric current, charge upon time, and it is what, change in charge upon change in time. Observe this one, at T1 charge Q1, at T2 charge Q2, then change in charge Q2 minus Q1, and change in time T2 minus T1. So we can write like, clear? And this ratio will be what, current, electric current, or we can say instantaneous current, and current at T. Its unit is coulomb per second and ampere. Its dimensional formula is this one, A1. It is a scalar quantity. It is having both magnitude and direction, but it is not a vector. Why? It is not following what, addition rules of vector. Clear? Then direction of electric current will be what? Electric current direction will be opposite of electron flow direction. Electron flow is what? Electronic current. This is what? Electric current. Electric current direction is conventional current, and it is opposite of electron flow, and this is the electronic current. So conventional current is opposite of electronic current. Clear? This is the direction. And 1 ampere current is what? 1 coulomb passing in a conductor in 1 second will be 1 ampere current. And in the nerves of what? Currents in our nerves is what? In order of microampere. So this is the basic theory of electric current. You revise these all points. These are very important for your NCERT point of view, your board exam point of view, your competitive exam, NEET and JEE also. You can take these all points, revise and again, then you can learn more and more. That's all about this class. Thank you so much.